YouTube channel TechSense Studio, and this is our first video. We do a temperature humidity system on human food, and I will explain or introduce to you guys about our project. Okay, my name is DHT22 and I'm a hardware designer and circuit developer. I designed the sensor security, power management system and wiring layout for the insert prototype. I also do the microcontroller interfacing and sensor calibration for accuracy. And in this project, we focus on measuring, analyzing temperature and humidity around the human food. We measure during three common physical activities like standing, walking and running. The motivation for this study comes from the fact that our feet are one of the most thermally sensitive and sweat producing parts of the body. When we wear shoes, especially for long periods or during sports, the enclosed environment can cause a rise in temperature and moisture. This trapped heat and humidity may lead to discomfort, blister, bacterial growth and even skin problems. Understanding how the food microclimate changes at the different levels of activity is very important. It can help designers and biomedical engineers develop smarter footwear that can automatically control or improve our comfort, especially for athletes, people with food conditions like diabetes. Therefore, this project aims to create a smart sensor-based system capable of measuring and recording these changes in real time. By doing so, we can obtain actual data on how the food environment behaves, which can then be used for scientific analysis, product design, and health monitoring. In summary, our project combines biomedical sensing, embedded electronics and data analysis to study human comfort from a real-world engineering perspective.
My name is Nonadira Balkis binti Nurizi. I am from IDC 5P. My role is to prepare reports, PowerPoint slide and presentation materials. I also manage report writing, referencing and ensure all technical and formatting requirements are met. Now, let's talk about the problem this project addresses. Most existing footwear or socks are not equipped with any sensors. They only focus on cushioning and design but doesn't monitor what's happening inside the shoe. When a person walks or runs, the temperature and humidity inside the shoe increase significantly, yet this change is rarely measured in real-time experiments. Previous studies often use static tests. For example, just measuring temperature while sitting or standing, which doesn't truly represent the dynamic nature of human movement. As the result, there is a lack of continuous monitoring system that can capture accurate data under real-life conditions. Without such data, designers can only guess what materials or ventilation system are best for food comfort. So, the main problem we aim to solve is how can we accurately and continuously monitor the microclimate conditions, specifically temperature and humidity around the human food during different physical activities. This system will provide real-time and reliable data, which can then be analyzed to understand how activity level affect comforts and to guide future shoe design. That's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Fahmi bin Zulkifli. and I am from IC 5B. Before I start with my topic, I would like to explain my role. And by the way, I am the project leader and system integrator for my team. Okay, for my role is to oversee the overall planning, coordination, and progress of this project. I make sure that every part of our system, whether it is hardware, software, or data processing, work together smoothly as one complete unit. As the system integrator, I am responsible for linking our sensor with the DHT22 microcontroller and ensuring that the data collected from the food is accurate and reliable. This also includes troubleshooting issues, checking connection, and verifying that our code communicate correctly with the sensor. Overall, my goal as the project leader is to make sure that everything runs according to plan, that the system we build function and well integrate, and that our project successfully demonstrate how temperature and humidity different during walking, standing, and running. Okay, for now, I want to explain about my main point is objective. Okay, our project has 4 main objectives that guide the entire research and development process. Okay, first, we aim to measure the temperature, humidity at different regions of the human food, such as the toe, midfoot, and heel. While performing various activities like standing, walking, and running, this helps us understand how different parts of the foot react to movement and pressure. Okay, second, we plan to design and implement a small wearable measurement system using digital sensor, which are controlled by an ESP32 microcontroller. This system allows us to capture accurate data directly from the foot in real time. Okay, third, we want to collect and analyze the data continuously so that we can study how temperature and humidity change with different activity level. By doing this, we can identify clear pattern between movement and environmental change inside the shoe. Okay, and finally, our fourth objective is to contribute to the development of more comfortable and breathable footwear. Through our scientific data and analysis, we hope to support footwear designers and researchers in creating smarter and healthier shoe system in the future. Altogether, this project work hand in hand to help us build a complete picture of how technology can be used to monitor and improve comfort during the daily activities. Okay, thank you.
Okay, for my role is sensor and data acquisition engineer. Is to focus on sensor placement, data collection and calibration on DHT22 and DS18B20 sensor. Ensure that readings are accurate under different activity level and environmental condition. Okay, go to the project scope. The study focuses specifically on 2 environmental parameters like temperature in degrees Celsius, relative humidity in percentage. We would test 3 basic activity like standing about 2 to 5 minutes, walking for 5 to 10 minutes, and running for 5 to 10 minutes. All experiments are conducted in a controlled indoor environment, maintained at around 22 degrees and 50% relative humidity to ensure consistency. The sensor used include DHT22, which is measure both temperature and humidity, and DS18B20, a pressure temperature sensor ideal for measuring skin or surface temperature. The system is controlled by an ESP32 microcontroller, chosen for its small size, low power consumption, and Wi-Fi or Bluetooth capability. This allows easy data transfer to a computer, smartphone, or cloud server. The focus is on collecting accurate, reliable data rather than building a full commercial product. However,
This setup provides the foundation for further wearable or IoT-based design.
My name Narofan bin Narazalan. My role for this project is develop the ESP32 firmware using Arduino IDE and microC environment, handle sensor data reading, Wi-Fi or Bluetooth, communication and data transmission to the PC or mobile application.
For this part, I will be explaining the significance of our project. This project is significant in several important ways. First, for footwear designer, it provides real quantitative data that can help in designing shoes that maintain comfort and reduce overheating. When we understand how temperature and humidity change inside the shoe during different activity, designer can improve material, ventilation, and cushioning to make footwear more comfortable and healthy for the user. Secondly, in medical monitoring, especially for diabetic patient or athlete, this project can play a valuable role. By detecting areas where temperature or moisture rises excessively, the system can help identify signs of foot problem or discomfort. This can be very useful for preventing injuries, infection, or overheating during physical activities. Thirdly, in research and agronomy, the data from our study support further analysis on human comfort, foot health, and thermoregulation. It provides researchers with accurate information that can be used to study how the human body responds to different activity levels. From a technological perspective, this project also demonstrates how embedded system and IoT sensor can be applied in biomedical and ergonomic research. Using simple and affordable components like the ESP32 and DHT22 sensor, we show that low-cost technology can be used to gather meaningful physiological data in real time. Overall, this project represents a small but meaningful step toward the development of smart footwear and wearable comfort system. In short, its significance is broad. It benefits industry by improving product design, medicine by enabling health monitoring, research by providing new experimental data, and technology by applying embedded system to human comfort sensing. By combining engineering and human physiological, this study proved that even simple, low-cost sensor can provide valuable insight into everyday comfort and care.
Hi, my name is Aina and I am the data analyst and research specialist in our group project. So my main responsibility is to analyze the recorded temperature and humidity data from the sensors and perform the graphic visual and create and interpret the experimental result to understand more on how temperature and humidity change across different parts of the insole during various types of activities. Now, I will be explaining our system overview for this project. So, we divided our system overview into three main parts. First will be the sensing section, second, processing section, and third will be the data analysis, data logging and analysis section. Okay, first, sensing section. We use temperature sensor to collect the temperature and humidity data. We place it into various parts of the insole, which are toe, midfoot, and heel areas. So the sensor will continuously detect both temperature and humidity near the skin, so we can monitor how the value change over time. Next will be the processing section. We use ESP32 as our main controller. So ESP32 will be collect all the data from the sensors, and ESP32 will work to transmit all this data through Wi-Fi for our monitoring. Okay. Finally, the last part is the data analysis part. Okay, we have collected all the data from the ESP32 and the sensors. So now we will do the analysis based on the real-time data. So we will plot the graph over time using MATLAB or Excel. So we can observe important trend on how quickly the food warm up or how humidity build up during different activities. As we know, we have 3 activities. So we will see how the graph change based on different activities. Overall, this system provides continuous monitoring and valuable insights into food condition based on temperature and humidity variation. That's all from me. Thank you.